that you've been working before in Spotify and other places, but now he's working more with back-end and front-end of YouTube, I guess. So say hello, applause, and let's listen to Arash. Thank you.
Hello. Привитания. Thanks for coming to my talk. I'm very happy to be here. Belarus so far have been very nice to me, and I'm happy you're having me here. So a little about me. I'm the chief maintainer of Luigi. Have anyone heard of it? You don't need to use it, but okay, some people. Oh, more. So currently I'm working at Google, but I will not talk anything about Google because then they will sue me. And yeah. So it will only be about Luigi today. Yeah, I'll introduce it, what it's for people who have not seen it and people who have only heard about it. I will show some examples so you get even more understanding of Luigi. And then I will talk a little bit like how you get parallelism with Luigi. Okay, first what Luigi is at all. So it was open source in 2012. It's from Spotify. I have a description here. So it says it's similar to GNU Make. Hopefully most of you have heard of GNU Make, and Luigi is very similar. The only difference is, well, it's in Python, and once dependency change, you don't recalculate everything, because Luigi comes from the big data world. And in the big data world, like rerunning something is not just recompiling a file, it's more like running this 2-day long batch process. And so all of this is influence how Luigi is designed. And yeah, Airflow is an alternative to look at before you start committing to using Luigi. It's in the same space. Luigi have spin-offs, so it's that popular. And the core of ETL pipelines, or I'm going to talk ETL later, is the dependency graph. So here you have a top root task, and it depends on things, and those dependencies depend on other things. And Luigi shows you what's going on right now, like what is done and what is running, and what it knows is eventually going to run, hopefully. Luigi does ETL, extract, transform, load. That's what you want to use it for usually. So let me just walk you through ETL. Extract means, okay, you get data from somewhere, maybe the internet, maybe your database. Transform is the part where you read it and like do some calculations and write it back, read it again, write, read, write. And load is like put it into maybe a database where you can serve things. This is a total made up example. You can do one extract part, which is getting data from the internet. You download it, you dump from one of your databases something, and then you transform. That's like you maybe use Apache Spark typically, not typically, but many use it. You use one of your internal local tools to do some other processing, and then you upload it somewhere to a database, and that can be serving web pages or music recommendations or whatever. And now getting to the code and Luigi, like each of these 5 steps I just shown you would translate to one Luigi task or one Python class. And what's inside these tasks, in these classes? So this is like really basic core Luigi, like for usage of Luigi. You have a task. You can have parameters. You have a method called complete, which says like, is this done yet or not? Typically, does this file exist or not? Like, and you have your dependencies, and you have the run method. The run method is probably using your dependencies, and after it's completed, it should make sure that complete returns true from then on. That's a well-behaving task in Luigi. Please feel free to ask any questions if there's something that was unclear. For more detailed questions, we can also take it in the end. So, okay. This is one hello world task I wrote. It's an example, so just so you get to see how it works. Can people read this? Okay, in the front at least. So in this one, okay, so there's no complete here. There's one thing called output, and output is basically like complete, but you know it's only a one file, so you don't need to have all that boilerplate. And the run method will open this file and write hello world, and then it's done. And this one has no dependencies. Okay, so let's run it. You tell Luigi, here is where my code is. This is when the name of the task, and do it like offline locally, local scheduler. That's what it means. It will print a lot of things. Eventually, it will say, okay, this is something that's pending that I will eventually run. And when it's finished, it will like print a summary what happened. And it says schedule one task of which one runs successfully and was the expected task. And then the file exists. So it did do something. Then we run the exact thing again. What happens? It will schedule, and I will not say pending, it will say done. It's already done. And then the summary will say schedule one tasks, but it were already done, so I did not run it. Okay, so let's get more, see more of Luigi, so you know what this is about. Again, okay, so this time I have two tasks. A parent task, I will show you later, and a child task. And the child task takes a parameter, and this exercise, yes, you get to see how this framework works. And it opens a file, and where is the file? It's in your temp directory, /presentation, and the name of the parameter. And what it does is it sleeps for 30 seconds, and it writes the evaluation of my param, which is a string, right? So this will be clear in the next slide. So the parent task, it requires the child task twice, and it contains Python expressions because it's going to be evaluated. And it also has its own output, and the run method for it. It's going to sum the results of the children. It's a bit weird. Now, I think, okay, so now I will also show you how the UI works. So this time I did not use local scheduler, I used the real scheduler, and then I get a nice UI. And you can see we had one parent task and two child tasks, right? And so the first thing, so this sleeps for 30 seconds, and the reason was so I can have time to take the screenshots. And here you see that the parent task and one of the child tasks are yellow, which means pending, they're not done yet, and the child task is blue, it's running. And okay, so that's expected. Then child task is complete, and the other child task is running. Do anyone know what happens on the next slide? Everyone knows what happens. Wrong! It's red. Why? Because I wrote a bug, and so what I did was I clicked on the red icon and see why did it crash, and I get a stack trace. This is a bit hard to read, but it says local target object has no attribute read. Let's look at the code again. I didn't capture with f open as f, which is like what you should do. So let's fix that code. Did I fix it? I think the slides. Oh no. So it also failed on the client. So before I fix it, I will. So that was on the web UI, right? And this was like in my terminal. It will say I ran two child tasks successfully, but I failed with the parent task. This progress looks sad face because there were failed tasks, which makes sense, right? There was also stack trace up there, but yeah. Let's fix the bug. I renamed the variables to something sensible, and I call the file descriptor fd, which makes sense. And now it should run, right? Run it again. Oh, I wanted to ask you, what result did you expect? But it was 21. Like 4 plus 6 evaluated, and the length of hello world 11. So that's why I get 21. Okay, I think that was the second part of my task. Yes.
I have a question. Maybe I misunderstand something.
Yeah.
Does Luigi like save the state of the running task and their results from run to run manually?
The scheduler. So it will try to forget them after like 10 minutes.
All right.
So it doesn't. But there's a history on a database plugin you can use. Yes.
Okay. You need to use some storage.
Yeah. By default, no. It because then like you might eventually have the problem of running out of disk space and stuff. Okay, so the Luigi scheduler, that was the UI part. That's what I'm going to talk about. Not how the UI looks like, but what it does and how it schedules the tasks. Okay, so here's a screenshot of it first of all. This was from the time when I was at Spotify, and the reason nothing is running because I copied the state file, and so actually were things running. There were a lot of failures too, so failures do happen in production, so do use something like Luigi. Yeah, so it's packaged together. It's also written in Python, but it can be written in anything else. Okay, the scheduler does a lot of things, but I'll focus on the core thing it does, so you get some idea. The workers, the one in the terminal, basically, it will tell the scheduler, this is a task, this is a task. Help me run them, or tell me which one to run. And the scheduler, in the second bullet point, it will tell the worker run that, or don't run this. In code or an API, you can add tasks and you can ask for what should I run. Okay, so now I'm gonna show you like an animation, and I will try to talk at the same time as it's running, and maybe you'll understand something by the end. If it's too complicated, you can just chillax. So we have this graph and one worker. So the first thing the worker does is look for all these like files or to check if the tasks are complete. And it does it in this fashion, right? And now it was done, so it was asking the scheduler, hey, give me some work. And now the first worker is running. And now a second worker comes up. It will do the same thing as the first worker, because how does it know like what the status is? It needs to redo everything, right? So hopefully the complete methods are fast, and you'll see that. And now it also asks for work. And yeah, you can do C, but you cannot do B. So that's why it got to do C. And now it's like this, they're working. And worker 1 finished. So it said, okay, that one is done. Give me work. And there was something to do. So now it's running B. And now B finished. And now it asks, give me work. And then realize, okay, there's nothing I can do because I cannot start on A. So it says PyConBy, and it dies. And now worker 3 starts, usually by cron. That's how you usually start Luigi. It will check all the tasks, but note this time, it will ask if C is complete. It's not, right? But it never checked for D, because it can infer that, okay, D depends on B. I mean, and B was already done, so why do I care about B's children? Yeah, and this is a repeat of it. Do you have any questions of what things happened here?
How do the worker get the work? By API calls or some kind of
Yeah. So there was this get work, right? And it will ask, like, give me something I can do. and then all the logic is in the scheduler. Yeah.
So the scheduler stores the
Yeah.
queue of tasks, and when the scheduler node is down,
Yeah.
we lost the queue.
If the scheduler is down, so down, I guess you say it crashes, right? And you bring it up 1 hour later. In that case, what I recommend is you start fresh. Like you delete all data of the scheduler and you start it again. What will happen is like what you have croned, like these workers will start again, and then they will reproduce everything again. And that's what I really like about Luigi. It's so simple that you can just bring it up again, and it will rebuild anything. You don't need like a third storage and like maintain that thing. So that's the Luigi model. Like rerun until it works, and yeah. Which isn't bad. This is pretty good. The last thing I was gonna tell you is the scheduler also do some other things. Resource limits. For example, if you can only run like 3 things at Hadoop for at the same time, the scheduler will know, okay, you cannot start running yet because there's already 3 guys running. If a task fails, which happens a lot, then it will say, okay, let's not run it immediately. You can set a limit. And if it fails like 3 times in a row, whatever you configure it to, it will like disable it. So don't run for a whole day or something. Just don't waste resources on Hadoop while others are using it. And it does a lot of things too. That's all I wanted to say. Am I too fast or too slow?
Well, you've been pretty fast, but let's say thank you.
Yeah.
If anyone wants to ask any questions, he'll hold the mic.
Thank you for the presentation of the great tool.
Thanks for coming.
So, would it be right to say that the workers you mentioned are effectively physical processes on one like physical or virtual machine, right?
Yes.
Yeah. So it means that Luigi doesn't let us scale out of one physical or virtual machine. Is that correct?
So per virtual machine, you
Yeah.
can actually, or per real machine, whatever,
Yeah.
you can parallelize in 2 more ways. One is like when you invoke Luigi, you can invoke it multiple times. It doesn't cost to have 5 workers on the same. I mean, like there's some extra Python memory cost.
Yeah.
And the second thing is you can also have a parameters dash workers, which is very confusing because every worker is a worker. But what it means, like only one Python process will spawn like sub processes that will also parallelize, and then we talk to the same scheduler. So these two.
Yeah. I mean, the following case.
Yeah.
So, if one of my Luigi tasks are fairly resource intensive.
Yes.
For instance, I need to make millions of HTTP requests.
Yeah.
And I need a lot of network. A lot of network bandwidth. So I would like somehow to have Luigi running this task on another machine or a set of machines.
Yeah.
What would be your recommendation?
My recommendation. So so the task that starts like the computer that starts Luigi, you said it's not the one that does the like millions of requests. It does it somewhere else. And I mean, like I would write my task to like run that command from another machine.
Okay.
Yes. And like if you have like tens of these tasks, like this is where like the resource limitations come in, because you know everyone would SSH to the same like heavy machine, and then we tell the scheduler don't let more than 4 of these run at the same time. That's the Luigi way of doing it.
Okay. Thank you.
Yeah, thanks.
Thanks for your talk. You just mentioned that if scheduler failed and if you run it again, it will reproduce everything, run every task. If I understand correctly, so What if my tasks are really huge, really expensive to reproduce? Is it any mechanism to control if this task were were done correctly, just to get the result of previously done task? Is there any internal mechanism?
Yeah, so maybe I was not correct in exactly what I said. What I meant was that the state in the scheduler, which is just a bunch of megabytes in this memory, that one will disappear when the scheduler dies. But hopefully you have like all these tasks, they have this complete method, right? And they will basically check, is this file on disk or not? And it will locally see, oh, it already exists. So we just tell the scheduler it's done. So this is something that nobody wants to run. This is something that is done. So yeah, it will not rerun it in that sense. It will just need to start again, look through every node, is this done or not done or not done, and then like tell that to the scheduler, and then the scheduler is back in trace. Yeah.
Okay. Thank you.
Thank you.
Anyone else?
Oh.
Just a quick thank you for your presentation. Just a quick follow-up on the previous question.
Yes.
You mentioned that, well, if the file is created, then the task is done. But what if our scheduler crashed when the file was being written, so it's incomplete?
The scheduler fails, or the task, the worker fails?
Maybe both.
Maybe both.
Yeah, if you check the completeness of the task when it's not like finished writing the file, how do you deal with that?
Oh yeah, that's actually, I had a slide about that, and then somebody said that's too much detail, so I had to remove that. The way you do it basically is you should never ever like write directly to the final path, because that's like saying to the world, hey guys, go use my data, but you're still writing it, and that's a bad thing. I added a bug to Luigi once that made, it was a Spotify, and I added this bug, and it basically did this thing, right? And what it ended up with was some people from the analytics team coming down, hey, the music labels say we only got like 70% revenue from yesterday. And we said, oh yeah, but yesterday was Thanksgiving. Yeah, go back to work. Like, don't worry. But it was actually this bug. So, fun anecdote. So to avoid this, what you do is you write a temporary path. And then when that, like when Spark, for example, is complete, you say, Luigi checks, okay, there was no error code. Now I move this file. And then it's published, and then the world can consume it. And there is tooling for this in Luigi. And that's another thing. Like, even if you don't need Luigi the tool, maybe you want to have Luigi the community that have done the same mistakes, and like you can hear from them, like to avoid doing the same mistakes. Yeah.
Thanks.
Hello. Can you name 3 main points where Luigi better than Airflow?
I haven't used Airflow, so unfortunately.
This is the answer, yes.
I'm sure I would never. I mean, what you should do is if you can try out both, if you have the resources, then try out both for small examples and see which one works for you. Yeah, because I know Airflow is a competing project, and I don't want to say Luigi is better. I don't think Luigi is better. I don't think Airflow is better. It depends on what you're doing. And I'm really happy that Airflow came out, because what it means is that there was like this sphere of people want to do data orchestration, and like Luigi was perfect for these guys, and Airflow was perfect for these guys. And before Airflow, everyone had to maybe use Luigi, and then they wanted to change Luigi in a way that wasn't a good philosophy for Luigi. So think like exactly what domain you are in, and what requirements you have, and try both and see what works for you.
So how did you start using Luigi and not Airflow? I'm here. How did you start? Why did you start using Luigi and not Airflow? Was it the time when Airflow wasn't on the market, or?
It didn't exist.
Right.
I mean, not externally. And Spotify, which were like the creators. I was at Spotify at that time, so 2 jobs ago I was at Spotify, and then we used Luigi, And of course, like they don't want to rewrite everything. Maybe even Airflow is better for Spotify. I have no idea, but I cannot speak for the company I don't work at now. But there's also this cost of you. If you have a lot of Luigi knowledge, you don't want to move, and vice versa as well, right? If you were using Airflow right now and you realize, oh fuck, I should have used Luigi. Maybe it's still worth good to stay with Airflow because everyone knows how to use Airflow at your company.
Cheers.
For example, I don't know how to use Airflow, so I would pick Luigi. But if you don't know any of them, you should make like consideration of both. It's the exact same thing for every software operating system or choice in life, I guess. Yeah.
Yeah, thank you for the presentation. And my question is connected to, so how are really tasks, so how we get them executing in parallel?
Yeah.
I mean, are they paralleled as a sub-processes or in separate threads, or we can configure something like that, or we configure the number of processes and so on?
Yeah, so it is just a precursor. It's not the answer to your question, but just first of all, Luigi never runs your thing. So you usually have like Spark that does like the real kind of like Spark. You tell Luigi that okay, run Spark, and then Spark will run open 1,000 threads or something. And then, but that is not enough. Maybe you want like 30,000. So you have like you want 30 Luigis, and the way you get 30 Luigis is one way is to just to just run it once and add this parameter dash workers 30, and then one Python instance will create like 30 child processes and run whenever necessary. The other thing, but then it will all run on the same machine, and that's not even possible sometimes because maybe just the Spark invoker takes a lot of memory or whatever. So what you do is you have like 3 computers, and then you say, okay, for each of these computers, run Luigi with 10 workers. And you can mix and match. And I mean, I've never seen that you only run one Luigi invocation at one. You have usually multiple, and different tasks that will have different graphs. Yeah.
Anyone else? Yes.
In our team, we are using Luigi for bind Spark and by jobs, and after that we are scheduling all this process in Azkaban. Maybe could you advise alternative ways how and using which tools we can do it? Maybe some internal mechanism in Luigi.
Oh, you use both Luigi and Azkaban?
Luigi for bind jobs,
bind
and Azkaban
is
organize all jobs.
okay.
So this
Yeah,
pipeline, and after that, Azkaban for scheduling running, like for day and so on.
Oh, so I haven't used Azkaban, so I don't know what it does for you that that you need a replacement for. But is it to run things on a schedule or?
Azkaban for scheduling running the whole process, like to start main task and after that all issues. Is it excessive approach?
Like if it works for you, I'm sure it's good. Like no, but really, like if it works for you, like how many times did it crash during last year? If it's 0, I wouldn't touch it. Like I probably had other problems. But if you find that it's slow or like eating resources, or you only want to use one of these systems, then consider kicking Luigi out or Azkaban out if it's possible, right? Or I mean, like yeah, I think it depends on the details of what you're doing. But you can ask me later with the details. Yeah, that's a good idea.
Hello.
Hello.
Thank you for your talk. My question is, does Luigi detect cycles in dependencies before running?
I don't know. I think it does. I think it will have like a hash map that it will see that it already exists, but I'm not sure actually. I'm not sure.
Okay.
Because, I guess I've never had this issue, but another interesting thing is not cycles, but one thing that's actually happened in practice all the time is like you have a data pipeline that depends on yesterday's data. And then that one depends on yesterday's, and that one also on yesterday, and then also on yesterday, and it goes on forever. And this is, by the way, if you ask me why is Luigi in Python, it's because sometimes you need programming language, you need Turing completeness. You need to be, say, like, you need 2 parameters, like the date and max recursion depth. And that's how you can set a max recursion depth. Back to your question.
Okay.
Sorry for...
I think it's a good case to try.
It's a good case to try, okay. But yeah, cycles usually don't happen naturally for me, but if they are a big issue, and it happens to you, feel free to send a pull request, like fixing it. I mean, like, come on, that's why I'm talking to you guys, so we get a strong community and you contribute back. And
any more questions? Yeah, okay.
One more.
Yeah?
So, what approach would you recommend for covering Luigi tasks or pipelines with tests? What are the best practices?
How you test Luigi code?
Yes.
I have experience, and I've heard from others who use Luigi that the best is, in this case, to, of course, like if you invoke Spark, all your Spark code should be tested. But the Luigi code is so like IO heavy that sometimes I feel it's better to just run it and see. No, but it's a very valid question. If there's some parts you think are extra sensitive, I would write tests for those. But most of it, I would not write tests for. I would like run it and see if it works. There's also like some tooling, for example, to if you just want to see how the tree expands, like there's a command line tool to like just print the graph. Don't run it, and then it will print the graph, and you see, okay, this is not garbage. But yeah, I mean, like otherwise, like you upload to a database. You like you read from Hadoop. You read from, if you migrate then to Google Cloud that Spotify did, you also read and write to that. And you read and write across them. And like mocking this all out would be just testing your mocks. It would not be like testing your actual code.
Yeah.
So that's from the experience I've had.
Thank you.
Yeah. The other thing, don't mix this up with all Luigi code is tested, by the way. So it's not like the internal Luigi code, but the user code, or when I write the user code, I just haven't found the need to test most of it. Yeah.
Let's say thank you to Arash for this inspiring Luigi talk.
Yeah. Thanks for listening. Yeah.
We now have a coffee break. Don't forget to say something about the talk next to the board if you liked it. And see you back to this